In the last video, we discussed some reasons to have one database per service that we create. So now in this video, I want to kind of circle this whole idea back to something we looked at just a moment ago, where I said that data management between services was really challenging. So we're going to take a look at a very simple application that we might try to build using this database per service approach. And you're going to see that very quickly we run into some gigantic data management issues. Now, to help you understand this quick example, let's take a look at a little diagram here. So let's imagine that this is the application that we're going to build. So very simple in nature. It's an e-commerce application, and it really has just three very simple functions to it. First, we have the ability to sign up. We have the ability to list out some products that a user can buy, like hats, pants, and shoes. And we have the ability to actually buy those products as well. Now let's first imagine building this very simple application with a monolith style approach. So remember, with a monolith, we've got all of our code inside of one code base, and we've got one database to service that. So here's a sort of monolithic style approach. We've got our monolithic server, and it has some code to sign up a user, list available products, and purchase a product. Now, of course, our monolithic server probably needs to store data somewhere. So maybe we create a database to service each of these different functions. So inside of this one singular database, we might have a collection or table of users, a collection or table of products, and the same for orders as well. Okay, this all looks pretty simple and straightforward. Let's now start to add in a new feature to our monolith. So let's say that we want to add in a new feature where we can show all of the products ordered by a very particular user. How would we implement that thing? Well, if you really think about it, we kind of need information from all of these different collections or tables right here. First, we might want to take a look at the user collection and make sure that the particular user that we're trying to look up information for exists. We might try to then look in the orders collection and find the order that a user has created. And maybe on that order, we would see the IDs of each product that was actually ordered. And then if we wanted to actually show information about those products, well, we'd probably have to do a query over to the products collection as well. So we're talking about accessing these three different sources of information to implement this one single feature. And inside of a monolithic server, yeah, this is all totally fine. No issue whatsoever. Okay, so let's now take this entire idea right here, this simple e-commerce application, but drop off that last feature. So how would we go back to this kind of scenario right here and split this monolithic server into three separate microservices? Well, it might look something like this right here. So we've got service A that would have some code inside of it to sign up a user. And as we just discussed, it's going to have its own little database. So inside that database, we'll probably record all the users who sign up to our app. We'll have service B for products and service C down here to purchase a product, which is really to like create an order and say that we want to purchase something. And so service B and C will probably have their own databases as well. Now let's imagine, once again, that we want to add in a new feature. So we want to add in a fourth service here, service D. And the goal of service D is to give us the ability to show not products, but orders made by a very particular user. So if we wanted to follow the same pattern that we used back in that monolith style approach, we could say that we want to have this service right here reach out to that database, reach out to database B and C. And it would have to do that if it wanted to get information about the user, find the order they had created, and then find details about those given products. But as we just discussed a moment ago, in this microservices style world, we do not allow a service to reach out to databases owned by other services. And so the question here very quickly becomes, how would we create service D? How in the world would that happen? How could we somehow get information required to implement this feature right here without reaching into these databases? And that is the crux of the issue. That is why data management between services can be really, really challenging. Of course, there's a lot of other tiny little problems along the way, but that's kind of the core issue here. We don't allow these services to interact with each other's databases, and so anytime we want to add in a new function or change functionality of an existing service, and we want to get access to existing data, how do we do that? It's a challenging little problem. So let's take a pause right here. We're going to come back in the next video, and I'm going to outline 2 general methodologies that we're going to use that would allow us to implement Service D.